Hi guys, it's Mrs. Eqns. It's Core 4, March 18th. We'll be working with systems of equations and matrices. My really cool picture. Okay, you'll see those really cool pictures later. Okay, webinars are Tuesdays at 2, and then get headsets if you want. Okay, my contact information is below. We'll be working with matrices, solving systems of equations, but this time they have x's, y's, and z's. Okay, here's my rules. If you need to, push pause and think through them. Okay, you can interchange any two equations, multiply one by one equation to a non-zero. You can add, multiply one equation to another, and those are the rules of what you can do. So what I'm going to do first for this one is always keep track of how you're doing Gaussian elimination. We want it in triangular form. Triangular form means you're going to, I'm going to go to the whiteboard real quick, where you have ax plus by plus cz equals a number, and then you have b2y plus second equation 2z equals a number. Then you have c3z equals a number. The reason why this is called triangular forms because it makes a triangle. Cool, so let's go back to our little problem. Watch carefully, push pause when you need to, and take notes and have lots of examples in your notes. So the first step, I'm just going to reorder my equations. I have equation 1, then I'm going to put equation 3 next, and then equation 4. Oh, just kidding, equation 2. And then each time I do a next set, they reorder. So equation 1 is x plus 2y minus 3z equals negative 28. And then equation 3 was negative x plus y equals negative, not equals anything yet, minus z equals negative 5. And then I have 3x minus y plus 2z equals 3. Okay, so that was my first step. My second step is I'm going to rewrite equation 1. And I get x plus 2y minus 3z. What I'm trying to do is eliminate the x's below it. If I simply take equation 1 plus equation 2, just add those two equations together, I get 0x plus 3y minus 4z equals negative 33. Okay, the next one's a little bit tricky. I'll tell you what I'm doing. I'm going to take negative 3 times equation 1 plus equation 2. And I'm going to go to the whiteboard and work that one. So, negative 3 times equation 1. Negative 3 times x is negative 3x. Negative 3 times 2y is negative 6y. Negative 3 times negative 3 is a positive 9z. And then negative 3 times negative 28 is a positive 84. And then I'm just going to rewrite equation 2. So I get, well, it's equation 3 now. Okay, I gotta go back. Back. This now is equation 3. Okay, so equation 3 in my new order, because every time you redo your equations, you have a new order of your equations. So this is going to be 3x back minus y plus 2z equals 3. And I'm just going to add them. 0 minus 7y plus 11z equals 87. So back to my really cool part here. So I have negative 7y plus 11z equals 87. Okay, so far I have a leading x and no x's below it. Now I want to have a leading y and no y's below it. So I'm only going to focus on the bottom two equations. So we will rewrite equation 1, equation 2, and then we will morph the other one. So x plus 2y minus 3z equals negative 28. Back. 3y minus 4z equals negative 33. And then this last one that we're going to do is I want the 3y and the 7y to be multiplied by something, different somethings. So I'm going to do 7 times equation 2, and I'll work it on the whiteboard, plus 3 times equation 3. So let's go to the whiteboard. Now let's kind of write down why we wanted to do that. So I have 3y plus, is that a plus or a minus? It's a minus 4z. Matters. Negative 7y plus 11z equals 87. Okay, so our purpose is to find a way to find a lowest common multiple that will get them, so when we add them, they'll be each other's opposites, so when we add them, they'll be 0. So our lowest common multiple would be 3 times 7, which would be 21. So if we had 1 to be 21 and 1 to be a negative 21, then when we add 21 to negative 21, we'd get a 0. So that's what we're going to do. How will 3 become 21? Simply if we multiply by 7. So 7 times equation 2 is 21y minus 28z. Okay, so then this is going to be 7 times a negative 33, which is a negative 231. And then we're going to multiply that by 3. So 3 times equation 3. Stuff is bumping things up and all over the place. It's annoying. Plus 33z equals 261. Add everything down. 0. Get 5z equals, this is annoying, equals 30. So then z equals 6, but we're going to write that on the other side. 5z equals 30. Okay, then we're going to work the problem. Wait, hold on. Then let's reinforce that this is our cool triangle. Whoops. Maybe I ought to shift that. Okay, that's our cool triangle. And so let's go back to the whiteboard and let's work things z on up. So 5z equals 30. Therefore z equals 6. Whiteboard, z equals 6. Let's go back to the whiteboard. If I know z equals 6, then I'm going to look at the next equation, 3y minus 4z equals negative 33. But I know that z is 6. So then it's 3y minus 24 equals negative 33. I get 3y equals negative 9. And then y equals negative 3. So I want to hold that information to the whiteboard. Y equals negative 3. And then I'm going to go finish her off. Now I'm going to go to the top equation, x plus 2y minus 3z equals negative 28. Uh-oh, I missed that little negative 28 there. negative 28. Okay, plug everything in. 3 in for my y, 6 in for my z. So then I get x plus 2 times negative 3 minus 3. I'm running out of room. 6 equals negative 28. These are bumping on me too. So annoying. So then I get x minus 6 minus 18 equals negative 28. Simplify x minus 24. That's a crazy x. These are just, I can't tell you. X equals negative 4. So my answer is negative 4, comma negative 3, comma 6. Super cool, guys. I mean, it's just like totally awesome. And yes, it does take that long to work a problem. Okay, so this component, if I ask you this question on a test, it is easy. Okay, I'm not asking you to solve anything. I'm asking you to write it in augmented matrix. Okay, an augmented matrix means it's going to look like a matrix. We got a dotted line here. This other part is just information. These are your x's, y's, z's, equals. You ready? Okay, the stuff in blue and the stuff in red is your augmented matrix. Coefficients. Oh, w, x, y, z. Oh, shoot. I don't have enough letters up there. Because it started with a W. It tricked me out. All you're going to do is you're going to pull off the coefficients. So 4w, what's its coefficient? 4. There's an x term, negative 5. There is no y term, so it's 0. And there's a 7 for the z. And then we're going to put negative 11 on the equals side. Okay, next row. Negative 1 for that w. There is an 8 for the x. There is a y, it's a 3. There is no z term. And then there's a 6. Last line. There's a 15 for your, oh, there is no w. It's 15 for x, negative 2 for y, 10 for z, and a 9 for z, for the equals. By the way, you can't actually solve that system because you have 4 equations. You have 3 equations, 4 unknowns. You can never solve it. You'd have to have 4 equations, 4 unknowns, and you can solve it. So, you ready? Take time, push pause, and do the augmented matrix for the next one. We did that one. So I'm just going to do my augmented matrix, put the dotted line there, indicates the equals side. All the red is required. So you need a W, you need an X, a Y column, a Z column, and an equals. Anything in blue is not necessary. So I can just simply go, I already know that this is 21, 5, negative 2, 7. Okay, so I'm going to look for my W terms in all of them. Negative 3, 4, 16, 1. My x terms, I have a 7. Second equation, there is no x term. Is no x term. A 1. The y terms, there's a 1. There's a negative 12. Negative 14. 2. My z terms, there isn't 1. 8. 1. And there isn't 1. This one has 4 equations, 4 unknowns. I can't actually solve it, but I didn't ask you to. Cool. So, elementary row operations is just using the matrices, but like just how I did a system of equations, this one I'm going to put it in a augmented matrix form. And then I'm going to do the exact same thing. It's just a little less clustered. So these are what they look like, okay? And then we're going to ask, is it in row echelon form? Row echelon form, notice my triangle is zeros. So let's look at A. Is it in row echelon form? There's no need for that one. So, no. Because your leading entry, your next leading entry, is this one in row echelon form? 3B. Got triangle of zeros. We're good. This one, is it in row echelon form? No, because this first entry needs to be a 1. So it is not. It is not. Anyway, that's just identifying stuff. This one's a super cool one, by the way. Okay, so what we want to do on this problem is we want to create an augmented matrix. So we have 1, 2, -3. I just do a straight line just because it's easier than the dotted one. The dotted one's what belongs, but it's easier to not do. And then 2, 1, -5, 8. Okay, so then what we want to do is we're going to try to get our triangles. We want zeros in there. So I'm going to use row 1 to establish that. Row 1. Just going to go ahead and rewrite it. 1, 2, -3, 7. And then I'm going to multiply row 1 by 3 and add it to row 2. So I'm going to go to the whiteboard to show you that work. So 3 times row 1 is 3, 6, -9, 21. And then just row 2 is -3, -7, -27, right? Not. Just need to write 9. Just need to write what's there. And then -12. And we get 0, -1, 0, 9. So that's where I'm going to go put in that new row. So I get 0, -1, 0, 9. And then for our next one, we're trying to eliminate the 2, so I'm going to take row 1 and times it by -2. -2, row 1, plus row 3. I'm going to go to the whiteboard to work that problem. So -2 times row 1 is -2, -4, +6, and -14. And then row 3 is 2, 1, -5, 8. So we get 0, -3, 1, and -6. Did I do that right? This is hard to do online, by the way. It's better to do in the classroom because then you guys can tell me where I screwed up. Okay, so then this is going to lead us to row 1 we're happy with. We're going to negate row 2. And then we're going to use -3 row 2 plus row 3. And just a reminder, each time we do these rows, they get new names again. It's just the nature of the game. So row 1 is 1, 2, -3, 7. And row 2 is 0, +1, 0, -9. And then let's go work this next problem. So we said -3 times row 1, times row 2, which is 0, +3, 0, -27. And then row 3 is 0, -3, 1, negative 6. So then we get 0, 0, 1, negative 33. Let's pause. I'm going to double check my work. So then that left us with z being negative 33, 0, 0, 1, negative 33. Okay, so then let's go to the whiteboard and let's identify what this means. 1, 2, negative 3, 7, 0, 1, 0, negative 9, 0, 0, 1, negative 3, 33. Okay, so this means that I have x plus 2y minus 3z equals 7. And that was that row. Then I have for this row, I have y equals negative 9. And then for this row, I have z equals negative 33. Okay, so I already know 2 parts of my answers. So I'm going to go identify that. I don't know x, but I know y is negative 9, and I know z is negative 33. So let's go find x. We have x plus 2 times negative 9 minus 3 times negative 33 equals 7. X minus 18 plus 99 equals 7. So x plus 81 equals 7. Subtract 81 from both sides, and x equals negative, oops, I'm writing the wrong thing. You can kind of see, equals negative 74. And I'll go fill that in. The more you work with this, the funner it is. The annoying part is it's really easy to make mistakes, and so that's why I like doing it in the classroom, because then students can call me out on my mistakes. Cool. Let's identify whether we can multiply matrices, and then we'll do one of them. Matrices, their order must be the same. This order, you always do row by column. The order of this matrix is a 2 by 3. This one is a 2 by 3. The order of the other matrices, this one's a 2 by 3, and this one's a 3 by 2. Okay, in order to take A times B, their orders must match in the guts. So if this is M and N, we're going to times it by N times, I don't care, P. The guts must match. Okay, so let's look at 1A. If I was to do A times B, what do I have? I have a 2 by 3, and I want to times it by a 3 by 2, or a 2 by 3 again. Can I do that? They do not equal, so you can't do it. If I switch them, you can't do A times B or B times A on that one. Okay, you just illegal. So let's look at 1B. We already know we can't do that one. So if I do A times B or B times A, let's look at their orders. A times B is a 2 by 3, and B times A is a 3 by 2. Do their guts match? Yep. Okay, what about my b times a? My b times a is a 3 by 2. And is that going to match my 2 by 3? Do my guts match? Yes, they do. Okay, so you ready? This is kind of weird stuff. Whiteboard. I'm just going to do the first problem. I'm going to do a times b. I don't want to do a times b over there because that whiteboard makes me really mad. So I'm going back to the PowerPoint and we're going to do a times b. Let's see if I got a blank page over here. I do. So I'm going to go to the whiteboard, record my information. Didn't work. You have no idea what I'm going through right now. It's really mad me. I'm writing stuff down lower and it bumps up. So I'm going to go to this blank whiteboard and do it. So I said I'm going to do a times b. It's kind of interesting how you do it. So super close attention. Fortunately, they have zeros in here, which makes our lives a lot nicer. And, okay, so this is a 2 by 3 times a 3 by 2. Our guts have to match, and the order of my answer, this is my answer order, will be a 2 by 2. Hope I could get it all on one page. Okay, so I'm going to use colors for row entry 1. It's really long. I'm going to take row 1 times column 1 and add the parts. So -2 times 2 plus 0 times -1 plus 3 times 9. For my second entry is going to be row 1 times column 2. So I get -2 times 0 plus 0 times 0 plus 3 times 3. Now if you need to like re-watch this, I would. Row 2, column 1, row 2, column 1. 5 times 2 plus -7 times -1 plus 1 times 9. I need another color. And then row 1, 2 times column 2 for R2, C2. So 5 times 0 plus -7 times 0 plus 1 times 3. Okay, so then I'm just going to write their corresponding parts. That's a 0, -4 plus 27 is 23. 0, 0, this is going to be 9. I'm going to do my other 0 one first, so this is going to be 3. So this is 10 plus 7 plus 9, so 26. So that's going to be my matrix. 23, 9, oops, that's not a very good 9. Change that to white. 23, 9, 26, 3. That's my answer. Kind of super cool, guys. I know, you loved it. You loved it. You loved it. All right, later, Gators.